Ever wondered why AI explanations sometimes feel like they're speaking a different language? Think of it like a doctor giving a detailed diagnosis to a patient. While the medical jargon makes sense to a colleague, the patient just wants the bottom line. This research tackles that exact problem, making AI explanations truly useful for anyone, not just experts. Here's the challenge. Most AI models are black boxes. They make decisions, but we often don't know why. Traditional methods try to explain their choices by highlighting input features, like pixels in an image or words in a text. But here's the catch. These explanations are one-size-fits-all. They ignore the user's background, needs, or even their level of expertise. Imagine a radiologist analyzing a lung X-ray. They'd want technical details about shadows or patterns. But a patient, they'd probably prefer something simpler, like there's fluid in the lungs instead of hyperdense opacities in the lower lobes. The same information, but tailored to the listener's needs. That's the gap this research bridges. The solution: a new approach called listener adaptive explanations. It's like teaching AI to speak the user's language. The key idea: using Rational Speech Act, RSA, a framework from linguistics that models how humans communicate effectively. Think of it as AI learning to read the room, adjusting its explanations based on what the listener knows and needs. Here's how it works. Picture a game where an AI, the speaker, has to describe an image to a human, the listener, without showing it. The listener must guess the correct diagnosis based only on the AI's words. Over time, the AI learns to pick the right words, like a teacher adapting their lesson to what students understand. But how does this actually work? The team used direct preference optimization, DPO, a technique that lets the AI learn from preferences rather than needing a model of the listener's mind. For example, if users consistently choose explanation A over B for a given image, the AI learns that it is better. No need for a listener model, just real-world feedback. They tested this on 3 datasets: bird images, everyday objects, and medical scans. The results: explanations that matched human preferences better than traditional methods. In user studies, people understood AI predictions more when explanations were tailored. This isn't just about making AI smarter, it's about making it more human. By bridging the gap between technical jargon and everyday language, we're not just improving transparency. We're building trust. Because at the end of the day, AI isn't just for experts. It's for all of us. So next time you see an AI explanation, ask yourself, is it speaking my language? Thanks for watching, stay curious, and let's keep making tech work for everyone. Now let's dive into the nuts and bolts. The researchers used 8 high-powered GPUs and 500 GB of RAM, enough to tackle some of AI's toughest challenges. Their datasets were equally robust. First, the Cub dataset, a birdwatcher's dream with 11,788 photos, each tagged with 312 details like feather color or wingspan. Then ImageNet, a massive collection of 14 million objects with 1,000 categories. They used 1.2 million images for training and 15,000 for testing, leveraging Concept QA to add custom annotations. Finally, CheXpert, 224,000 chest X-rays with radiology reports, but with simplified terms like fluid outside the lung instead of pleural effusion to make explanations clearer. The team built 2 core components: a speaker AI's explanations and a listener AI's understanding. The speaker used a pre-trained model called CoCa, which analyzes both images and text. They fine-tuned it to focus on pragmatic explanations, meaning the AI doesn't just list facts, but tailors its words to the listener's needs. The listener was a transformer model, like a super smart reader that evaluates those explanations. They tested 3 speaker types. 1. Literal speaker, spouts every detail like this bird has a bill and wings. 2. Pragmatic speaker, guesses what's important based on context like this bird has a yellow belly. 3. Topic speaker, zooms in on distinctive features like black wings and a black forehead for the American goldfinch. Humans classified birds based solely on AI descriptions. The topic speaker nailed species like the black and white warbler by highlighting unique traits. The pragmatic speaker outperformed others for the Wilson warbler, where a specific detail, its bill shape, was key. The study showed AI can sometimes beat humans, but only if its explanations match how people think. For example, the pragmatic listener aced the American goldfinch, while humans struggled with confusing jargon. That's why collecting real human feedback is crucial. Machines need to learn our preferences, not just logic. This research isn't just about better explanations. It's about creating AI that collaborates with humans, respecting their knowledge and needs. Because the future of AI isn't just about what it can do, it's about how it connects with us. Stay curious, and let's keep pushing the boundaries of what's possible.